Hi everyone, thank you so much for joining again. In this video, we will show you what you can do with the NaviCenta if you have an account. So let's go to the NaviCenta. As you can see, we're already in the NaviCenta, but we're not logged in yet. So if you want to see how you can get to this place, you can look at the previous video. In order to log in, I click on this login symbol and I type in my login and password. In order to get that, you will have to create an account. You can find our email address that you can request an account under this video. So I'm going to click login. And it will look the same. However, you will notice here, this lock is now open. This indicates you're logged in. And you can now click next to it on the hamburger menu, select plugins, and type in your URL. This is where you can load your plugins. So two are already in there, overlays, which is very useful, and air plugins. We want the iPlacenta plugin. So we're going to type in the link and click load. The plugin will load on the right-hand side of your window. This plugin includes the options Xplore, Omics, Variant, and Mass Spec. We will focus on Xplore for now. Here you can explore entities that you can find in the submaps as shown in the previous video. Let's zoom in for an example. So let's take this one. Under regulators, if you want to know what the specific regulators of an element are, you can select your element here. So you can click on it, or you could as well type it in here. In this case, we selected it. And if we scroll down, you can see it has one regulator. If we scroll up, we can see it's reactive oxygen species. So this makes sense. Let's select a different one. NOx4. This one has more regulators. And you can find this if you scroll down. You can also download this information if you're interested in it. This is useful if you've already identified a biomarker or something that was significant in your experiment and you want to see what you could research next in the placenta-specific context. If you scroll further down, you see the option downstream enrichment. Let's click on it. We can scroll further down and we can again type in an entity that interests us. Let's pick the one that we can already see here. And we click Add Element. You can type them in one by one or all together. I like having the overview and control and typing them in one by one. And they will show up here. You can perform in silico perturbations. You can knock them out completely, or let's uncheck this. You can up or down regulate them to a certain degree here on this handle. Let's up regulate them. And if you scroll further down, you will see how this would affect other phenotypes with the level and adjust the p-value. You can again then click on whatever interests you, and it will show you in the map and highlighted in colors how that would affect the network. This also helps you identify further targets for your next experiments. If you scroll further down, you can see upstream enrichment. We can click on that. Let's actually reset this one so we don't get distracted by this in silico perturbation we've done here. Scroll down to upstream enrichment, and we can manipulate the phenotypes we're interested in. Let's look at this one. Fatty acid synthesis. We can also regulate this one up and down, and it will be indicated. If you scroll further down, we can see targets of this specific phenotype. These are sorted by sensitivity and specificity, and whether we know if it's a positive or a negative target. You can hover above them, and it will tell you which elements they are, including values for their sensitivity and specificity. You can download this information as a TXT file or as an image if you like it like this. This again helps you identify targets for your next experiment. You can further download your data here under Data Export. However, I prefer these more specific options. Let's reset this so it doesn't distract us. And this leads us to our second option that we're going to cover in this video, omics. Here you can upload your own data. If you click on Choose File, it directs you to your own computer. So I know where the data that I'm interested in is this one. And this is the data set I actually got. It's a public data set. We're going to look at it in a second. I select it and click Open. If we look at the file, just to know what kind of options I should choose here, let's open this. You can see we have the gene names, we have the log2 fold change, and we also have the p-value. I'm going to close this. So I know we have a p-value, so I'm going to select this. You can decide how to deal with multiple transcripts by mean, highest FC, lowest FC, etc. We're going to go with the mean right now and leave everything on default, and then click Read Data File. We know how many probes were mapped. We scroll down, and we want to see the result. You can choose to optimize settings, which is a further way to normalize your data. The data I've chosen was already normalized by the authors. So I'm going to click Estimate Phenotype Level. We're going to scroll further down and find our results. We can decide whether it should be normalized, how it should be normalized, which statistical method to choose. The p-value threshold, we're going to keep it at 0.05, and below that, the phenotypes that are affected based on the data that we've just provided. So we can look at the graph, we can see the phenotype, we can download it as well here. But we actually want to know, based on the data we provided, how would this phenotype change? So this is an estimated log2 fold change for the phenotype. So endothelial activation would be downregulated. Natural killer cell chemotaxis would be downregulated. There's also an estimated p-value. It gives you the number of samples that fall into this. Let's scroll down. Not all of them are downregulated. This, for example, calcium-mediated signaling is upregulated. We can again click on the phenotype that interests us, and it will tell us which element in the map, element or elements, as in this case, were up or down regulated. So this is red, so we know these two entities were upregulated, which leads to a general upregulation of calcium-mediated signaling. You can download this information as a phenotype result or the regulator scores. Both are very interesting to look at. This was a very basic introduction to what you can do with the NaviCenta. We recommend you just have a look, and if you have specific questions, we did put our contact below this video so we can provide more support. Thank you so much for joining us to this tutorial.